All right, so here in the tree class, I'm going to create a new public method, public boolean equals, which gets a tree object. We call it other. So this is the public method we're going to call from the outside. We also need a private method for recursion. So let's add that here as well. Private boolean equals. This private method should have two parameters, node first and node second. So we're going to compare two nodes for equality, and then we're going to recursively call this method to compare the left and right subtrees. Okay. Now, in our public method, we're going to call this private method. So we return equals and pass the root of the current tree as well as the root of the other tree. This is how we kick off the recursion. Okay. Now, in this private method, we have a few scenarios. One scenario is that both these nodes are null. In that case, we want to return true. So if first equals null and second also equals null, then we return true. The other scenario is where neither of these nodes is null. So if first is not null and second is not null either, at this point, we should compare the value of these two nodes. So we're going to return first dot value equals second dot value. But at the same time, we want to look at the left and right subtrees. So this is where we use recursion. So here we add and equals. Now we pass first dot left child and second dot left child. Similarly, we want to check the right subtrees for equality. So one more and equals first dot right child and second dot right child. So this was our second scenario. The third scenario is where one of these nodes is null, the other is not. That means these two nodes are not equal. So we simply return false. This is how we check two trees for equality. Now, here's a question for you. What kind of traversal algorithm have we used here? Here we're using the preorder traversal algorithm because we're comparing the root nodes on line 152. And if they're equal, then we look at their left and right subtrees on lines 153 and 154. So we're visiting the root first, followed by the left and right subtrees. This is preorder traversal. Now let's test our code. I'm going to duplicate this tree and call this second tree, tree 2. Now we want to rename all these tree instances together. So I put the caret here. If you're on Windows or Linux, press Control. If you're on Mac, press Alt twice. Now press the down arrow. This is what we call multi-cursor editing. So we're going to edit all these tree instances together in one go. Once we're done, we press the escape button. That's it. Finally, we're going to call tree that equals tree 2. Let's run our program. There you go. These trees are equal, but what if we remove one of the nodes in the second tree? Now they're not equal, so our algorithm is working properly. Now, what if we pass null here? We get a null pointer exception. So we should go back to our tree class and fix this issue. So here in the public equals method, we check to see if the other tree is null, we're going to return false. Let's run the program one more time. The exception is gone. Beautiful. Next, we're going to look at validating binary search trees.